Hello everyone, welcome to a quick overview of Q-Seg, a quantum annealing-based unsupervised image segmentation algorithm. I am Supreet Mysore Venkatesh. First, here's a glimpse of the highlights of Q-Seg. It is significantly faster than the classical state-of-the-art solvers like Gurobi. Next, we developed this method focusing on harnessing the power of existing quantum devices, thus demonstrating an improved scalability. It has also been tested on real images from satellites using real hardware. When we consider segmentation, we can choose to either go for supervised or unsupervised technique. Domains like Earth observation or medicine have a requirement of large amount of reliable label data, which is infeasible. Thus, we have to go for unsupervised technique. There are several traditional image processing techniques which can be broadly classified into these four categories, each of them having their own pros and cons. And the least explored among them is the graph-based segmentation due to its sheer complexity, which eventually makes it a sweet target for quantum computers. Also, with respect to quantum computers, there are two hardware implementations available, but for this work, we mainly focus on quantum annealers in order to obtain the segmentation mask. Coming to the methodology, graph-cut segmentation captures both spatial and spectral information. We first convert the image into a grid graph of this structure. The edge weights are assigned based on a similarity metric, then find a minimum cut in this graph which can be decoded to get the segmentation mask. Moreover, one can formulate this problem as finding minimum or maximum cut based on whether we considered similarity or dissimilarity metric. Either way, it is an NP-hard problem. Given the mathematical definition of the minimum cut problem, we can reformulate it as a quadratic unconstrained binary optimization problem with no loss in generality, which means the translation of the QBO is still aimed at solving the original problem of finding the minimum cut. With this transformation, we have tested the implementation on a real quantum annealer called the Advantage 2.0 manufactured by D-Wave, accessible as a cloud service. The experiments were conducted on a synthetically generated images of varying sizes, performed a comprehensive runtime analysis of the entire process and compared the results with that of the classical state-of-the-art solver Gurobi. Even with internet latency and waiting time in the service queue, we outperformed Gurobi, which runs locally on our system. In an hypothetical scenario for a fair comparison with a dedicated QPU on site, considering all the times except the internet latency and waiting time, we find that Q-Seg is significantly faster. Furthermore, we were not only fast, even the quality of the solutions were compared with Gurobi in terms of the cut value, which is slightly better than that of the D-Wave annealer. While working on Q-Seg, we came across another work making use of annealers for segmentation that got out on arXiv, and it is also taken into consideration. And on comparing the problem formulations, we found out that the other approach requires a lot more number of physical qubits, which implies that we were having a better scalability with the existing and near-term quantum technology, or in other terms, Q-Seg is easily embeddable onto the existing quantum annealers. We also tested our approach on forest cover segmentation, a real-world dataset, deliberately choosing this dataset as the ground truth labels were very noisy. With noisy labels, any supervised learning technique would utterly fail. Also, the results of Q-Seg were better than the recent segment anything model, as this was a very specific use case. Another stream of experiments were performed on flood mapping use case, where the qualitative results show that Q-Seg has a comparable results with that of the state-of-the-art method tailored for this use case, which shows a promising potential of Q-Seg. Finally, to conclude, Q-Seg is significantly fast and demonstrates a better scalability. With Q-Seg, graph-based segmentation techniques becomes feasible and the implementations are open source for reproducibility and one can readily test it out on their use case. For my contact details, feel free to reach out to me. Thank you.